title for this talk is actually the same title I use every time I talk about sports analytics. I sort of came up with this title some time ago, and I just tend to recycle it even though the content changes. So when Ryan asked me to give this talk, I'm really used to talking about the projects that my research lab does. And typically, we do projects that are pretty large scale. These are things that take 18 to 24 months. It involves a ton of tracking data, usually supercomputers, that kind of stuff. And so, I was ready to sort of talk about the asymptotics of semi-Markov models. And then I realized that this talk is supposed to be about sort of life in a club and sort of some of the lessons I've learned. So I'm going to not talk about the sort of technical stuff and talk a bit instead about some of the stuff I've learned along the way. My first thought was, I'm going to talk sort of about some of the best practices for analytics within a club or within a team. And then I realized that sort of what I think of as best practices now is quite a bit different than what I thought 2 years ago when I started at Roma. And so it really comes down to, hey, if this is being recorded, and chances are I'm going to look back in 2 years and look at what I'm saying now and think that was really stupid. So what I'm going to do instead is talk a bit about just a sort of a handful of the lessons that I've learned over the last few years. So those of you who are here the last couple of years, you'll know that both Dean and Dennis talked a ton about communication. So basically their whole talks are about communicating with coaches, getting information across. So I'm not going to spend a ton of time on that, but I do want to talk about a couple things that I've learned that I think might be interesting to you. And then I want to talk about sort of two different perspectives that I have. The first is that I think that the way we treat analytics people or data people within clubs is kind of wrong. And the other is that just about the sort of, when you go into a club, ways that you can continue to be the best that you can be. So the first thing I want to talk about is data visualization as a tool. So one of the first projects that my lab did was this idea that, okay, defense in the NBA and soccer as well, to be honest, is hugely understudied relative to offense. Right? Offense is really easy to measure, defense is not. And so we had this thought, like, if we can take tracking data and we can just figure out who the defensive matchups are, what the markings are at any given moment, then we can sort of figure out what the points against are for a given player, sort of the defensive responsibility. And so we built this fancy hidden Markov model to detect defensive matchups. And then we used it, we had nice visualizations like the one you see here, all linked up with video. And then we went to actually present this to a GM. And so we sort of described what we were doing, and we said, hey, the idea is to assign defensive credit for goals against. And so we got this, we showed, so the first thing we do is we figure out what the matchups are, and then in the end we get responsibility. And so we sort of had this table on the right, which was sort of just like a wall of numbers. And what was fascinating to me, this is like one of the first things that I ever presented to a person within a club, is that when we were showing the visuals of the animation, and the GM was just enthralled. And then as soon as we jumped to sort of the Excel spreadsheet of numbers, the enthusiasm dissipated quickly. And so we realized there's a way better way to show this. So out of sort of our error in showing a wall of numbers, we realized, hey, coaches and GMs, they don't think in terms of spreadsheets, right? They think in terms of what's going on the court or on the pitch. And so this led us to display this information like this. So coaches and GMs and fans in general are used to looking at shot charts in the NBA. So they're used to looking at charts which show where a player took his shots from, where he's a good shooter from, where he's a bad shooter from. This, in contrast, is sort of the defensive analogy of that. So what you see here is every shot taken against James Harden and against Kawhi Leonard. This is a few years old, before I worked in the NBA. So the James Harden and Kawhi Leonard. And what you see here, basically, is the size of the dots represents that player's propensity to prevent shots. So you see James Harden, all his dots are really big, so he's not preventing shots, is the quick takeaway there. But Kawhi Leonard, it might be hard to see in the back, but the whole perimeter around the three-point range here is all these tiny little dark blue dots. And so the tininess means that when he guards guys, he gets shots taken against him, but he gets, when he's guarding guys out on the perimeter, they take way less shots than they would against a typical defender. And similarly, those dots are all dark blue, which is to say that even when those guys do get shots off, they're way less efficient. So the other thing I should point out with Kawhi Leonard is that in the mid-range, sort of very, at least this old season, very sort of typical. And so we went from this spreadsheet of numbers, sort of describing and ranking players, to this. And as soon as we put it in this form, which clearly was not a small amount of effort, then people got it, right? And so it was really this lesson that presenting raw numbers and raw information is usually the easiest path, but it's almost never the best path. And one thing I will say is just a quick follow-up is that once we presented it like this, and they sort of understood this, they wanted the charts, but then they also wanted the raw numbers. So the raw numbers sort of came later once they understood the concept. So that's my first thing, is that think really carefully about data visualization. How do the people actually that you're presenting to actually think about the problem, the underlying problem, and how do you sort of turn the data into that? So we actually first started off with this with like bar charts of the players' regression coefficients, right? That was like the obvious thing to do. But we thought, hey, we have spatial representation. We have the court, we have colors, we have sizes. Let's actually put it on the court. And we came up with a completely different visualization that was much cleaner and easier for coaches and GMs to understand. The next thing I want to talk about briefly is a project that we did a few years ago. It was called Court Realty. And this project started out with this basic notion that different players and different teams value different areas of the court better, or more than others, I should say. So in other words, some teams really want to get the ball in their hands in the corner 3. Other guys want to get it under the basket. I apologize to those of you who don't know any basketball, but I did see someone wearing bright red NBA socks, so I know there's at least one of you. So this chart here is basically looking at a typical team, how they value different areas of the court. And so under the basket, you see this like sort of dense area where they value, and then in the corners. And we just could not get this idea across to coaches. So when we started to do this, we sort of said, hey, this is the areas. The basics idea of the model is that if I have the ball and I have a lot of open space and I pass to my teammate and my teammate is really tightly defended, the idea is that our team or me values that space that he's in more than mine. So I'm trading sort of my big space for his small space, and therefore his space is more valuable. Right? That's the basic idea. It wasn't until we came up with this analogy to connect it to real estate. And we told someone who was an assistant GM at the time, and we said, it's the same analogy as if you had a little 300 square foot apartment in Manhattan, and you said, hey, for the same rent, I can get a 1,000 square foot apartment in Queens, so I'm going to move and get more space. Even if you don't know how much that person's paying in rent, you can learn something about the relative value of the two different locations. So as soon as we made that analogy, they said, oh, I get it. So we really, I guess my first point was that it's communicate on the level that coaches and GMs think, but the second thing would be that oftentimes you need to pull in metaphors, you need to pull in analogies, and that can be really, really powerful to help get information across. So the next thing is another project that we did looking at expected possession value. This is from a few years back, but the idea of this project was that we wanted to be able to, through any point of a basketball possession, say what the expected number of points that are going to be scored. So the idea is that a typical possession in basketball is worth 1 point. But you can imagine that if Steph Curry, who has a wide open corner 3, that it's probably much higher than 1 point in expectation. In contrast, if your team's worst player is being double teamed with no time left on the shot clock, it's probably much less than 1. And so we had this sort of stock ticker for an NBA possession. And one cool byproduct of this was that it allowed us to get down to the level of individual decisions. And we could say, given all the spatial temporal things that are happening on the court right now and everything up to this moment, what are the typical decisions that a player makes? And how does each of those decisions increase or reduce the expected value of that possession? The equivalent to soccer here, by the way, is basically instead of thinking about the expected value of possession, it'd be something like, what's the probability that your team scores next? So we had this model, and we had this plot here. And we actually presented this to the Spurs at the time, which is what this is showing, Kawhi Leonard. And he said, OK, in this situation, Kawhi Leonard could have made all sorts of decisions. He could have passed to one of his teammates, he could take a shot, or he could move, he could dribble. And so we can sort of figure out with this really sort of complex multi-resolution model what the values of those and the probabilities of those are. And it turns out that the best option is for him to pass down into the right corner there, or left corner, I guess, from this perspective, down to Danny Green, who basically has a wide open corner 3. But when we presented this, the feedback we got was, but you're missing the fact that Tim Duncan is setting a screen on this player, and so they're about to run a particular play where Danny Green cuts across the baseline. And we sort of sat there and thought, oops, we missed the key feature. The point being that we had this model that sort of captured things quite well and data that sort of could get us so close, but we were really missing the sort of underlying play structure that was going on. And so in the end, we realized that the metrics that we got, which said, okay, which players are good decision makers or bad decision makers, which players make the right decisions, that kind of thing, it works well in aggregate. When you get it down to the sort of individual decision level, it doesn't pan out. And this is sort of like related to the ecological fallacy in epidemiology, where you sort of make conclusions that make sense for the group, but don't necessarily make sense at the individual observation level. Maybe an analogy to soccer is that expected goals, when you add up expected goals, we've seen a few presentations this morning, you get sensible results, but oftentimes when you look at an individual shot, due to the nature of the model or the nature of the data, what's missing from the data can be a bit misleading. Okay, so I just have some random thoughts before I talk about the next areas. The first is that showing rankings of players is really only good for starting arguments. So this is something that's been borne out multiple times in my last few years. I should say, the first thing I'll say is rankings sometimes are good. If you're proposing a new metric, rankings can be useful, right? You look at the top 10 guys, okay, the top 8 are just what you expected, and then there's 2 interesting ones, and it creates a nice discussion. But when your GM asks you to get, who are the best centers in the league, and you just give him a ranking, prepare to spend a long time in his office. Because the point is that really, like a list of rankings, no one's going to agree with you, and you're going to create all sorts of issues that really don't get at the nuance of rankings to begin with, which is that inherently, if you're ranking someone, you're using an individual metric, and that might be an aggregate, but ultimately you're ranking these people on one number or an opinion. And so that one number is almost never the right number, which brings me to my next point, is that athletes are not a single number. So when I started working in this, I would often say things like, oh yeah, this player is the best defensive player in the league, right? Or this player is like top 5 defenders in the league. I would say things like that all the time, right? And now I've drastically changed the way that I talk about things. So I'll say something like, for his position, this player is 95th percentile in rebounding, and he's 90th percentile in steals, and he's 99th percentile in turnovers. That makes him like in the elite of defenders in the league. So instead of just sort of making a blanket case like, hey, this guy's at the top, I say, hey, he's elite on multiple aspects, which puts him in that top group. So it's all about sort of reframing the discussion to sort of not make it about a single number, but making it about a suite of things that represent the athlete. And the last thing is don't slice the pie too thin. So we had this situation a couple years ago where we were looking at different players' shooting efficiency from different areas of the court. And we were looking, this is the year that Steph Curry won MVP. And Steph Curry, for those of you who don't follow basketball, basically won Most Valuable Player that year for his incredible ability to shoot long-range shots. He would take a lot of shots that were like 30 feet away from the basket. And so we had all these zones, and what we would do is we would sort of look at these different zones, and we would look, okay, which players are a lot better or worse than expectation from that zone. And so most of the things made sense, except when we looked at these like long-range shots, these shots that are sort of 5 feet and more beyond the three-point line. And it turned out when we looked at these shots, the first thing was like Steph Curry was right in the middle in expectation. And we're like, this seems really weird. Like this guy literally just won Most Valuable Player for his ability to shoot these long-range shots. But for some reason, when we looked at it, at a first glance, it came out that he was average. And then when we dug into it, we realized that there was about 100 of these shots in the sample, and he was 92 of them. So he was average because he was the whole sample. So this is like an important thing to keep in mind that oftentimes, and this really happens with tracking data especially, you might think tracking data is this ton of data, but what inevitably happens when you start working with tracking data is you say, okay, find me every situation when the right back was here and the left back is here, and it's an in-swinging corner with this guy moving here and this guy moving here, and you get your answer, and it turns out that you're looking at one single observation. Right? So again, make sure you're very cognizant of what I would call conditioning statements. So there was a guy who was a professor with me at Harvard a few years back, and his whole tagline was, conditioning is the soul of statistics. And so that's a really, really key thing to remember, that conditioning, which is to say you want to sort of get some analysis but condition on some information. So I want to find the best shooter conditioned on it coming from this region of the court. Or I want to find the best finisher conditioned on it being inside the box or something like that. Conditioned on being under the age of 21, conditioned on being in these leagues. So when you start to do all this conditioning and sort of making conditional statements, make sure that what you're conditioning on isn't sort of filtering you down to be too small of a subset. Okay, so at this point I'm going to sort of diverge from what Dean and Dennis talked about. And I'm going to talk about a few different things. as I look at this, the irony is not lost on me that I'm a Canadian speaking to Brits using American English. But let me just say this, that oftentimes the way that a data person is treated in a club or in a team is that when it comes to draft time or it comes to free agency or whatever it might be, that there's, you might be sitting in the boardroom and there'll be the sporting director and the scouts and the analyst, the data analyst. And you might all be sitting around the room, and at some point, someone looks at the analyst and says, what does analytics say about this guy? And I think that's the completely wrong way to go about it. I think when you're in a club, when you're the analyst, when you're the analytics team representing the club, your aim should not be to be the smart guy in the room. Your aim should be to make everyone else smarter, right? So it's not about being the smart guy in the room, the guy with the answers. The idea should be, let's educate everyone to make everyone else better at their jobs, make them more objective, make them more data-driven. All right, so this is something that we do a lot at the Kings, and so here's an example. So one thing that I realized right away is that there's this thing that always gets talked about with analytics, and most of it's just media spin, that analytics and scouting are like, batting their heads against each other. First off, I have never seen that to be the case. And the second is that usually analytics people or scouting people respond, no, these things complement each other. I think that's garbage too. What really you want to think about is analytics and numbers and objective information makes the scouts better, like they make everyone better. And so I have yet to meet a scout that doesn't want every single piece of information she can get. Do you know a scout in your organization that you say, hey, we have all this information about this player, and they say, nah, don't really care, right? I have never seen it, and I've worked with multiple clubs. So I guess this gets to the point that you don't think about analytics and qualitative and quantitative as these sort of separate worlds that sort of, maybe you think about, okay, they don't clash, but they sit side by side. Instead, think of it as sort of a way to sort of, they should integrate. And what I mean here, for example, is that if you have a scout go and watch a match, right? So they watch this match, they sit there for 90 minutes, and they say, oh man, this player was incredible. They made 98% of their passes. Right? So you're looking at this and you say, this is amazing, 98% of their passes. But then, so they're going to write the report, say this player is an incredible passer. But as an analytics person, what you could do, for instance, is give them the information that says, actually, this person on average only completes 70% of their passes. So you just witnessed a really outlier of a game, and that's going to change the way they think about it, right? So providing them the context of that game, providing them information about what they just watched can help them give more insightful reports, right? All right. So at this point in the talk, my plan was to talk a whole bunch about Spalletti and my time at Rome. But the problem is, in Merrick's talk, Spalletti was in the bottom right quadrant. So I can't do that anymore. So the time that I was in Rome, Spalletti and I had a few conversations with my 8 words of Italian and his 8 words of English. And really nice guy. I enjoyed my time with him. But the truth is that he really didn't have much a direct interest in analytics. And so I thought long and hard about how does information flow in this? How does he get his information? And how can I, instead of sitting down with him directly, how can I make his information better? And this is something, by the way, we do at the Kings as well. And I realized when we sort of started talking that all of his information about opponents, about players, comes through the video scouts, right? His advanced scouts that watch the sort of upcoming team. They probably typically watch 2 or 3 matches, put together a video, and then deliver it to the coach. This is, I think, pretty standard, right? And so I realized, hey, if I can't sort of have an effect directly to the coach, let's just sort of improve the information that he's getting. So it was less about, you might think, okay, I want to sit down with the coach and describe to him why, this crossing strategy is not a good idea. It might be better to say, hey, let's figure out who are his influencers and influence them instead. And this is something that I found really valuable. So for the video guy, for instance, at Roma, we would build out tools and infrastructure to help him make better information. So instead of choosing his information on just watching a couple games, he'd have information from many dozens of games, and a lot more detailed information about the way teams would build up their attack, where they would sort of tend to strike from, where they'd move the ball, all that kind of stuff. So this is my first suggestion, is that when you're thinking about educating and sort of raising the analytical awareness within your club, raising the sort of propensity to use objective information, think about how information flows. Think about how people are influenced, and try and inject yourself into those pipelines. The second is that be prepared when the bar is raised. Do any of you know who Peja Stojakovic is? All right, some hands. So Peja Stojakovic is like this legendary Serbian basketball player, and he actually happens to be our vice president of player development at the Kings. And so one of my first meetings when I got there, I'm coming from a football club where, any use of numbers or information was sort of very challenging, to say the least. One of the first meetings I had was with Peja Stojakovic, who picture like this Serbian guy who's 6'8", like looks like my wife would divorce me for him. And the first thing he says is, we're talking about this player, and I haven't said a word, I'm just sort of observing. And he says, oh yeah, this player is good for 20 points and 10 rebounds and 6 assists a night. And I said, what? Can you imagine someone in your club talking that way about a player? Can you imagine them saying, oh yeah, this guy's good for 0.6 XG per 90 and a solid 95% pass rate and 12 passes in the final third per game? I have never heard that, right? But in basketball, the use of analytics and the presence of analytics teams within the organization has been around much longer, 5, 10 years. And in fact, the bar has been raised. And I talked to Peja after this and I said, did you think that way when you were a player? And he said, never, but the amount of information that we're getting has changed the way we talk about the game. And so I guess I bring this up to say, be prepared because the bar will raise. And maybe it actually doesn't raise for every person in your organization. Maybe it only raises for a subset of them. But be prepared when it does raise to sort of continue to push it forward, because you might feel like you're sort of hitting a brick wall, but eventually there will be a change as people start to use this information to sort of speak about the game more intelligently. Another example of this is that I've experienced a lot this sort of dichotomy of scouts, and you'd often hear like, oh, which players do you like? And I'd be like, oh, I like that guy, I don't like that guy, right? And I remember saying like, can't we be a little bit more intelligent about this, right? To say like, I like that guy, I don't like that guy. You'd think that we could be a bit more like, oh, I like that guy because he really creates the open spaces and he opens up passing lanes, right? And so this is another thing that I noticed in basketball is that there tends to be a lot more like use of that kind of information, and say, oh, yeah, this team is second in the league in touches in the paint, and they're third in the league at creating open corner 3 opportunities. And this was not the case 5 or 10 years ago. So this will happen. This sort of evolution will happen, as impossible as it may seem. The last thing is that you use the power of technology to make improvements across your club. So this relates to how information flows. So realizing that we don't actually have the ability to sit down with the coach like on a daily basis. They're on the road a lot. In the NBA, we play basically every other night. So this is 2 things that we do at the Kings. The first here on the left is a wall of TVs that we have in our practice facility. And so the analytics team that I lead, we've built essentially a visualization tool that takes all sorts of data viz that we've built that's basically trying to influence people within the club. And we basically like brainwash them with analytics through these big TVs all day, every day. And so it's as simple as, the one on the right is basically trying to tell people that 3 is greater than 2, which is a hard sell in the NBA. And then we have things like, okay, we're monitoring all our players shooting, and we can look at the trends over time. If there's some video there where they can see their recent performances, et cetera, et cetera. So realizing that, hey, a mechanism for getting information across, it doesn't have to be a sit-down meeting where you're delivering some report. It doesn't have to be even some tool that you've built that people are using. Think of creative ways to create an objective-based, data-driven culture. And one of the ways we did it here is this sort of wall of TVs, which are sort of using things that we're regularly updating, some videos, some static images, sort of just trying to help people be aware of ways that we can get better. The thing on the right there, that's actually every shot taken by one of my staff, Colin Montag. I would show you one of our players, but that's probably not a good idea. So we track every single shot in our practice facility. Okay. In the last 2 months, we've tagged about 350,000 shots. So just think about the scale of that for a minute. Think about what that takes. 350,000 shots. So we also happen to get even our non-players shots, like the trainers and the analytics guys. But the idea here being that when you think about something like, think about, for instance, what Merrick was talking about today, that how many shots it takes for you to say that this player's actually exceeding XG, that he's actually a better than average finisher. It takes a ton of data. The same is true in the NBA. If you're looking at, for instance, corner threes, which are sort of the shots in the far corners, it would take multiple seasons, basically, for you to say whether a player's a good corner three shooter or a bad corner three shooter. Because it's like, imagine you have a coin and you flip it 10 or 20 times. It's almost impossible, based on those 10 or 20 flips, to say whether this is a 30% coin or a 70% coin. Right? Very, very hard to sort of do the inference and say, hey, this coin is biased or it's not biased. And so what we do is we track everything in practice, because that allows us to say more conclusively that this player is getting better, he's getting worse, that he's working hard, he's not working hard, he's good from this area, he's not from good this area, he's hitting his targets, he's not hitting his targets. And so I should say that this isn't, if you might imagine the nightmare of manually tagging 350,000 shots. That's not how we do it. We have essentially sensors that sit above our baskets that manually get the location and the entry angle and the sort of left, right, and the depth of every shot. And then we have a tool built which essentially automatically figures out who the player was. So, we're using technology essentially to allow us to do things that would have been impossible 5 years ago, allow us to get a lot more information about our players than you can ever get from a small sample size of games. This is particularly true. Like, imagine if you have a football club and those sort of 10 guys that didn't hit the pitch, and most nights, night after night after night, you're getting no information on them. You're getting no data on them. And so how do you learn about them? You need to start tracking what's going on on the pitch for practices. And so that's something that I think the best clubs and the best teams in the NBA, this is what they do, is they monitor practices, they monitor every weight that the player lifts, they monitor every shot that they take, every pass that they make. And of course, you have to do things like adjust, like our best shooters shoot 90% from three in practice, right? I shoot like 2%, right? So but you have to adjust for this, because to sort of account for the difference between practice and game. So anyway, that's sort of what I'm saying, is that to think about how information flows across the club, how you can use technology to sort of influence it and improve the way information flows. All right. So the last thing I want to talk about is growth. One thing I've observed throughout my time working with clubs and teams is that typically when people get a job on a team, whether this is true for performance analysts, definitely for statisticians, data analyst type people, is that you tend to stagnate quite a bit in terms of the growth of your sort of analytical skills. And so one thing I want to sort of make a quick note of here is that a lot of the projects that we've done, and even within the Kings, could not be solved with regression or logistic regression or k-means clustering. Right? If those are the tools in your toolbox, you're going to be really limited in the projects you can solve. So I was actually planning to, I had this slide all built, and then Dean Oliver, who happened to give this talk 2 years ago, had this like tweet, what is it, 4 days ago, that was like perfect. And he basically said, the great thing about sports analytics is that I've had to learn or relearn network theory, evolutionary dynamics, geometry and trigonometry, machine learning statistics. And this is true, I would say that from my experience as well, that the number of times that the sort of basic methods aren't going to cut it is vast. And if you sort of, the typical hammer and nail analogy here, if your toolbox is limited, you're going to be also sort of handicapped in your ability to improve the club and use data to improve the club. All right, let me give a very simple example of this. So we did this project, some of you may have seen it at Sloan, called Possession Sketches. And the idea there was that we wanted to take a huge corpus of every possession in the NBA, and we wanted to find similar possessions. So we wanted to find all the plays of a particular type and group them together. And so the idea here is that we have every play in the NBA, it's roughly, in a season, that's roughly about 100,000 plays, okay? So possessions, I should say. So we have 100,000 of these. Some of them are sort of set plays where the players run a sort of a coordinated action, and some of them are not. And what we want to do is we want to take this sort of, imagine we have 5 shown, but let me jump back. We have 5 of these shown. We have 100,000 of these, and we want to sort of group together similar ones. So we actually use something called topic modeling, which actually latent directed allocation. There's a great paper out there, or a poster, I should say, that uses LDA as well for a similar or related sort of idea. But we use this idea of topic modeling, which is something that's really common in the text modeling world. And what that technique does is basically takes a huge corpus of documents. So imagine like every article in the New York Times, for example, and it'll group them together and say, okay, this batch of documents are about biology, this batch of documents are about finance, this batch is about real estate, this batch is about politics, this batch is about sports. And I don't know if you can see the writing, but that's kind of the example here. So the top four, the top one is Trump and healthcare. The top right is Jeff Sessions and GOP. Then it's McElroy playing golf with Trump, and then Colin Kaepernick's anthem protests. All those are about politics. And the bottom four, this is about Golden State Warriors, and then March Madness and the NCAA, as well as the two middle ones are about sports. So sort of the orange circles are about, those are about sports, or sorry, those are about politics, excuse me. And the bottom four are about sports. And we wanted to do something similar, use that method for NBA possessions and use it to sort of cluster possessions. But we needed some definition of words, so what we had to do is we had to take every movement on the court with player tracking data and segment it up and essentially cluster it. So you could say, okay, we have a possession with all 5 players running around, and let's turn that tracking data into some notion of a document, right? So what we did is we took every single movement that happened and we sort of sliced them all up, and then we clustered them using a technique called Bezier Curves, which are something that are used in video game design. And we clustered every movement. So we basically went from these 100,000 possessions, we sliced up every player's movement, and that led to 4.5 million little segments of movement. And then we clustered those 4.5 million segments into like about 250 words. And here the words are sort of these sort of similar actions. And the idea there is that we can say, hey, look, in all these possessions, there's a baseline cut, which is like this one here, sort of from the right to the left. And this is the sort of symmetric opposite of it. So we are able to sort of extract out that, instead of using words, just thinking about colors, we can say, okay, in this possession here, we had player 1 doing the purple action, and players 2 and 3 both doing the red action. And then at some point, player 3 switched from the blue action from the red action to the blue action. Shortly after that, the player 1 switched from the purple action to the green action. Then player 2 and player 3 both switched actions, etc. And we get this sort of representation of a play or possession as a document, where with the colors here are the words. And this allows us to do things like the following. So here is a map where every dot is a possession that ended in a corner 3 for Golden State Warriors, Houston Rockets, and San Antonio Spurs. So again, let me repeat that. This is every single one of these dots represents a play or a possession from one of these teams that ended in a shot from the corner. Okay? And you can see that basically the closer these dots are, the more similar the semantic content of that play is. Okay? So 2 dots which are side by side, it means those 2 plays are the same play basically. And so I'm going to zoom in on that red cluster, the sort of bottom right cluster, and show you quickly how this looks. So they both happen to be plays by the Houston Rockets. One thing I'll get you to watch for is James Harden's going to baseline cut, but in this case he doesn't take the corner 3. And then watch again the one on the right here. You can see James Harden in the bottom left. He's going to cut across right there, up to the other corner, and this time he actually takes the shot. Okay? So they both have identified at a first glance a baseline cut that leads to a shot, right? The interesting thing is that this method doesn't care who took the shot, it just sort of identifies that. Let me show you something else. So watch the point guard. The point guard is the guy that started with the ball. He's going to hand the ball off to someone, and then he's going to drive and plant himself under the basket. Okay? And the idea is that as Harden's running along the baseline, the point guard who's sort of planted under the basket is going to get in the way, put a set of what's called a screen on James Harden's defender. Okay? And watch, it picks this up. So watch, he's going to run down, stop under the basket right there, boom, and then tries to get in the way of his defender. You see that? Now watch this one, same thing. So Prigioni, who's the point guard here, he's running under the basket, and the pin down screen is right there. And so if you look at this play here, his man got totally stuck under the basket. Monte Ellis had no idea what was going on. So I'll just show you quickly again, because I think it's fascinating, that it picked up this structure, essentially this give and go, or this giveaway, this sort of drive into the basket, setting the screen. It wasn't a very good screen. See, his man sort of chased him through, which is why he didn't get the shot. And then in this case, the screen is set. You'll see, so the guy that just gave away the ball, he's running down, and he sets the screen right there. And James Harden is then wide open. So basically, we said, hey, these 2 plays are very, very similar. And when you look at the semantic content of them, they're almost identical. So the reason I show this is not because, oh, we've like revolutionized the way to think about basketball. This is like a pipeline thing that would happen in a sports team, right? You're tagging data. For instance, our video guys at the Kings hand tag an incredible amount of games. But you can use this to make their world much more efficient, much faster, much more automated. But I guess the point of this is to say, okay, we can do this, but this task I can almost guarantee you could not have been solved with regression and t-tests and k-means clustering. So it's important to sort of continue to expand your technical skills, not just statistically, but also sort of thinking about, like, this requires parallel computing and the use of clusters and databases and all that kind of stuff. So just I guess my takeaway here would be continue to push your technical knowledge beyond the sport itself, because that will help you solve problems. Both Dean and Dennis talked about how they spend so much time learning the game, and I think that's critically important, and you should go back and watch those talks if you can. But I want to say it's also important to continue to push yourself forward so that you can continue to sort of help derive value for the club. Okay, so the last thing I'm going to talk about is, or second to last thing I'm going to talk about is know the surrounding science. So I had this tweet a while ago that actually caused a bit of a fury. When I said the sports science industry basically says that they can predict injuries with a high rate of success, right? So they can say with some high probability they can detect ACL injuries or they can detect non-contact injuries. But the truth is that the research is not so clear. The sports science research is very cut and dry about injury prediction as being really hard or unsolved, or even the papers where there is a signal, it's really small samples, et cetera. So when I started working in sports analytics, I'm a statistician. Like, I have a PhD in stats and machine learning. When people would talk about predicting the draft, and saying this guy's going to be good and this guy's going to be bad, and they could say, hey, we're using deep learning and we predict the draft perfectly. Usually my answer will be no, you're not, right? Because I know that world and I know that what they're saying they can do is not possible. But then I had a situation where I was at a conference and some person told me, hey, we can reduce injuries in your club by 50%. I was like, this is amazing. This guy, like, I got to bring this guy into the owner, right? And the truth is that I got sold a little snake oil, and I should have probably learned and done some research. And so I spent a lot of time reading the literature. There's a ton of literature out there on this. Same with sort of physiology, et cetera. Just sort of expanding beyond just sort of the technical statistical expertise, trying to learn some of the surrounding area. So this would sort of, to tie it in a little bit, is to say, hey, look, Dean and Dennis both said you need to learn the sport and you need to communicate the sport. I agree with that 100%. It's also important to push your own technical skills. It's also important to sort of understand what's going on around you, understand what the sports scientists are talking about, understand what the trainers are talking about, understand what the doctors are talking about. The last thing here is that we tend to get a little bit stuck onto sort of letting the data drive our decisions. Can anyone tell me what this player has a lot of? Goals from set pieces, right? So one of the things that I see all the time, whether it's in blogs or Twitter or wherever else, is that we tend to let the data drive the analysis, right? And one thing I've realized in my time working in this field is that it's important to not have the data dictate what you say and don't say, but instead, if you're trying to solve a problem, sort of admit the limitations of the data and say, hey, look, here's what I'm trying to solve, but the data only gives me this and this and this. So even with tracking data, you can say something like, I'm trying to solve this problem about defensive intent, but I don't have information on where the guy's hands are, where he's looking, or which way he's facing. So sort of, I guess the point here is to think about, don't try and frame the problem in terms of the data that you have. Frame the problem and then admit sort of the limitations and assumptions that you have to make given the data that you have. Will allow you to sort of convey the information a lot more clearly, and that sort of better addresses the issue. The other thing I want to say about this is that, there's been some great talks this morning about using tracking data, and I think there's still a general sort of question: can you use tracking data to help a club? The consensus from basketball 5 years ago was that we don't know. This data is new. Not every team has it. It's really unclear whether tracking data is valuable. The consensus now, 5 years later, is like every person, without a doubt, tracking data helps you understand the game much, much better, and is a lot closer to what coaches think about. The same is true in soccer, I would debate, and that's, if you look at what coaches talk about, right, they don't typically talk, they won't talk about, oh, this guy's great at creating like high expected goals, or this guy's great at, maybe they'll talk about passing, but what they tend to, you hear them talk about is spacing and movement and creating openness and creating passing lanes. And so really the sort of dominant discussion and the dominant sort of ideology is primarily around spacing and movement. And so really I think tracking data is something that's going to become, just to be aware of, I should say as an aside that I didn't plan on having a Voronoi on there, but after the Twitter debate, someone now owes me a beer tonight for having that up there. So what I want to show here is just like you can see here, this is a handful of the sort of words from the possession sketches project that I showed earlier. Some stuff that I'm doing with Javier from Barcelona about identifying spaces, how players create and space for themselves and for others, and then some stuff that we've done using functional clustering. The point is that the set of problems, a lot of times I hear, oh yeah, tracking data is going to help us to answer the current questions we're already answering, but with better accuracy. And I say, no, that's not really the case. What tracking data allows you to do is answer problems that were completely unanswerable with event-level data. And that's true in the NBA when we had play-by-play, and then we got tracking data. It allowed us to say things like, when this guy drives to the basket, he creates open space for the corner three. It allows you to say things like how closely the player's defended when he takes a shot, who the player defending him is when they took that shot. And so, in brief, it gives us this ability to quantify things that coaches have been talking about forever, but the data sort of wasn't catching up. And now we have the ability to use this data to answer a lot more questions. Now, again, before I wrap up, I will say that this is not easy. Right? Anyone who's, in fact, many of the tracking data talks today talked about how hard this data is to work with. Right? And as I mentioned earlier, a lot of the projects that we've done are not something that you would just, hey, let's load in the tracking data and let's quickly figure out who's creating space for their teammates, and I'll send you the report tonight. It's not really how it works. Most of these projects have taken months and months and months. The timeline will come down. Second Spectrum, for example, in the NBA, has done a great job of sort of productizing a lot of the analysis that sits on top of tracking data, and this kind of innovation will come to soccer as well. So I will stop there and field questions.
Thank you very much, Luke.